This video is going to cover percent composition. Most of it should be a review, as we've already taken notes on this. We'll go through a couple of problems together, and then you'll have a chance to try a few on your own. So the example we used in class was a fruit basket, and we talked about how we can find the percent composition by taking whatever it is we're looking for, so I'll kind of use that as like a question mark, over the total. And then because we're talking about percent, we always want to multiply that by 100, and that will give us our percent. So for example, if I wanted to know the percent of apples in this basket, it looks like I have 2 apples, and then I have a total of 1, 2, we'll say 1, 2, 3, 4, 5, 6, 7, 8 pieces of fruit. So 2 divided by 8. And then I can't forget to multiply by 100. If you want to go ahead and divide 2 divided by 8 and then multiply by 100, that's fine. Or you can just do it all at the same time. It does not matter. But your answer comes out to be 25%. So 25% of this basket is apples. So the key thing is we always have what we're looking for, which is our question mark here, and then we always divide it by the total. So let's look at some real problems. This goes along with the practice sheet that you were given. We're going to do the first problem together. So it talks about calcium chloride. The first thing that I do is I write down my 2 different elements in this compound. I have calcium and I have chlorine. And then if I look, I can see that I actually have 2 chlorines. I know that I have 1 calcium because there's no number there, and we know that if there's not a number, it's really just an invisible 1. So I have 1 calcium, but I have 2 chlorines. So now I need to look and try to find the molar mass, which is from the periodic table. So on the periodic table, if I look for calcium, I know that the mass is 40.078, and if I find chlorine, the mass is 35.45. So now, since I only had 1 calcium, that mass doesn't change. My calcium is still 40.078, but now that I have 2 chlorines, I have to remember to multiply that by 2, so I come up with 70.9. So now if I want to get the total, I can just add these numbers together. So my total is actually 110.978 grams. So this gives me the first step in the problem, right? If I want to know my percent composition, in this case, I'm wanting to know what percent is calcium. So my total is 110.978, and then I want to take calcium, and then I can't forget that I want to multiply it by 100. I'm going to go ahead and divide this time. So if I divide the top number by the bottom number, I get 0.3611, and there's some other decimals beyond there. But then I have to remember that's not my final answer, right? Because it's in a decimal, and I know I want to do percent, so I'm just going to multiply that by 100. So I get about 36%. So my answer, how much is calcium? 36.11%. The second one we're going to look at is actually the third problem on your sheet, iron hydroxide. And it wants to know the percent of iron. So again, the first thing I'm going to do is I'm just going to look and count what I have. So I have iron, I have oxygen, and I have hydrogen. So once again, I'm going to look at my little numbers because I do have some of those here. There is nothing next to the iron, right? So I'm going to assume, I know that's an invisible 1. So for iron, we just have 1. For oxygen, we start out with 1, but there's a 3 there. So I have to remember that there's actually 3 times 1. 3 total oxygens. Here, I'll actually put that in black. 3 total oxygens, and then hydrogen is going to be the same thing. It starts out as 1 hydrogen, but because there's a 3 outside the parentheses, I actually have 3 hydrogens. So now I can look at my periodic table. I can find the mass. So 1 iron is going to be 55. And then my oxygens, I'm just going to go ahead and round to 16 to make my life easier. And then for hydrogens, it's 1.008. So when I am doing my first step, I have to remember to add in the total number that I have. So for iron, since I just had 1 of them, that number doesn't change. But for oxygen, now that I have 3 that each weigh 16, that's a total of 48. And then for my hydrogen, since I have, again, 3 that each weigh 1, my total mass for hydrogen is 3.024. So now I can add all 3 of those up together and get my total, and I get 106.869. So that's my math part, right? Kind of the first step is I just have to add everything up. I have to get the total. If I want to find the percent composition, in this case it's asking for iron, right? I know my first step. I know that I have to divide by the total. So since I've already added all of that up, I'm going to write that down. And then my iron is 55.845. So I'm always taking the final number that I have for that element. If I had asked for percent oxygen, let's just pretend, I do the same thing. I have my total, which is 106, but then I would need to take the total oxygen, which is 48. So if I wanted to do my math now, I can go to my calculator and then I can do all of my division. And then don't forget, you have to multiply by 100 to get that percent. It comes out to be around 52.3% iron. And then it comes out to be about 44.9% oxygen. And again, I have multiplied my decimal when I first did this division. Don't forget, you have to multiply by 100 at the end to get your final answer. Okay? So if I wanted to, I could also find my percent hydrogen. Okay, and then ideally all of these percents would add up. So I'll go ahead and do it just so that you can kind of see a way that you can check yourself. So my percent hydrogen, I'm still taking the total, but this time I'm going to take my total hydrogen. So 3.024. I'm going to divide, and then I'm also going to multiply by 100 because I don't want a decimal answer. And this is, let's see, 8%. Okay, so let's go over just a couple of things with this example. Notice for each one of these, I'm always using my total on the bottom of the formula. My percent composition is always divided by the total. And then I'm always using this final number for my element. I'm not starting out, I'm not taking 16 when I look at percent oxygen. I'm not saying 16 divided by the total because I have 3 oxygens, so I can't forget about that. So I'm always going to take these final answers right here. If I wanted to double check myself, I could take my percentages that I got for all 3 of these. If I add them up, they should all equal 100% because we know that a percent is out of 100. So if I add up all 3 of my answers, it should total up to be 100. So if you wanted to check yourself to make sure that you did the work correctly, if you calculated all of them, then you could add them up to get your answer. This problem only asks us to find iron, so you could have stopped there. But if you want to check your answer, it helps to find all 3. Now on your own, you're going to try at least 2 more of these problems. We have already completed this one and this one together. So you have about 5 more that you could choose from. Just pick 2 out of the 3 or out of the 5. If you want to do more, you can, but I will be checking to make sure that you did at least 2 additional problems on your own.